In our final section for this chapter, we call it Identifying Special Quadrilaterals, and that's 8.6. This section doesn't really have any new properties as we go forward looking at our special quadrilaterals. What it's doing now is we can put these all together, and now we need to get practice in if you've given a certain shape, you can identify what type of shape it is and why, and it really forces us to utilize the properties we've discussed. So we've seen that a little bit as we've gone through these sections. You've seen problems in why is it a parallelogram, why is it a rhombus, why is it a trapezoid, but now we've got to put it all together and make sure we can narrow down to find the correct reason. So what may be easier than looking at this will actually be we have a tree diagram to look at quadrilaterals. So we're going to work through and find all the certain properties we have. Once we have those, then we can look at a couple examples and see how we can utilize that. Now, a quadrilateral. If we start with the quadrilateral, very beginning, we really know two things. I know I only have one number here, but let's say we have two things about a quadrilateral. We know there's four sides, and the other thing we know is that the interior angles have a sum of 360. So angles add up to 360 and there's four sides. We will classify something as strictly a quadrilateral if none of these other properties work. If none of the other properties work, we're going to call it a quadrilateral. But it's likely that most of them that we look at will be easier to classify as something else. Keep in mind anything below a quadrilateral in this tree is still a quadrilateral. It's just special properties that qualify it. Now, let's start with where we looked first with parallelograms. Parallelograms, we know that opposite sides are parallel. We know that opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Run out of space there. And diagonals bisect each other. Those are the five properties we have for a parallelogram. If we look at an object and we can find one of those that fits, or even if we're looking at a parallelogram, we can use those to help us out. Now, when it comes to proving that you have a parallelogram, keep in mind this one, consecutive angles or supplementary, is not used. What we use in place of that is that you have one pair of opposite sides that are both parallel and congruent. You can look back at 8.3 for looking at ways to prove the parallelogram, where 8.2 was your properties of parallelograms. From there, we went to, let's look at a rectangle next. We know a rectangle has four congruent angles. They're also right angles. It also has diagonals are congruent. That's different than a rhombus, and a rhombus has four congruent sides. We then had two properties in regards to its diagonals. One is its diagonals are perpendicular. Then the diagonals bisect opposite angles. Finally, we come down to a square, and a square is really a combination of a rectangle and a rhombus. It has four congruent sides and four congruent angles. Now, also, since it gets the fact it has congruent angles from a rectangle and congruent sides for a rhombus, we can combine any other properties we have for those to fit with a square. Next, we'll go to trapezoid. A trapezoid, strictly a regular, normal trapezoid. Nothing special about it. Its one property we know is it has one pair of parallel sides. Not at least one, just one. Because if it had more than one, it'd be a parallelogram. But nope, it is a trapezoid. We had a more specific trapezoid, and we call that the isosceles trapezoid. And that was where the legs are congruent, as well as base angles are congruent. Keep in mind that would be these angles would be one pair and those angles would be another pair. And then finally, diagonals are congruent. Finally, our last quadrilateral was a kite, and a kite has two pairs, I don't know if we can fit this here, but two pairs of consecutive congruent sides. It also has perpendicular diagonals, so diagonals are perpendicular. And then finally, one pair of opposite angles congruent. And that would have been those two angles in this case. Now, we also have a note here about the midsegment. Midsegment did apply to a trapezoid, and that worked for a trapezoid and an isosceles trapezoid, and we can use that for finding the length of that midsegment. But these are all the properties we should already have. If you're not sure about any of these, you should go back and look over the videos where they talk about them more directly. Parallelogram was 8.2 and 8.3. Rectangle, rhombus, and square were 8.4. Trapezoid, isosceles trapezoid, and kite were all 8.5. And you're not going to help here trying to figure them out and get them all sorted as you go through the homework if you haven't gone through and identified and be clear on the properties. If you want to use this as you go through and build upon that, that would be good, but make sure you have a good foundation to where all of these are being used. Now, let's look at a couple examples where we're going to see how we're going to use the fact we have this diagram with all of these properties. So, we have a quadrilateral DEFG with at least one pair of opposite sides congruent. So let's just draw a quadrilateral. Now I realize it looks like a rectangle. That doesn't mean it's a rectangle. I drew it like that. But we're going to mark what we know. So at least one pair of opposite sides congruent. So let's mark one of them. Okay, it has at least one, so we know that one is good. So we need to think, what could it possibly be? Well, if we start over here, trapezoid, we don't have any congruent sides. Isosceles trapezoid, we have those legs are congruent. Those are opposite sides, so it could be an isosceles. Trapezoid. We then, let's see, a kite we know has consecutive sides, not opposite. A parallelogram looked at opposite sides being congruent, but more than one pair, so that may be more when we get to the multiple sets. So let's mark the other pair congruent. If we do that, now it fits to be a parallelogram. When it is a parallelogram, keep in mind it also works for a rectangle, rhombus, and a square. So a parallelogram has one pair, really has two, of opposite sides congruent, a rectangle, a rhombus, and a square. Now, the sides that, or the shapes that did not, was the regular trapezoid, which just has one pair of parallel sides, and the kite, which has consecutive sides being congruent. Okay, move down to our next set. We need a most specific name for the quadrilateral. So if we're going to call it a quadrilateral, we need to have a reason for it. So first one we look at, we have 50, 50, 51, 51. We know opposite sides are not the same. So that eliminates a parallelogram because a parallelogram needs opposite sides congruent. So anything below that is also gone. Trapezoid, we don't have anything about opposites or the sides being congruent. Legs for isosceles, we would need that. That's not the case. So it looks like a kite would be a good candidate for us. Now, why would we pick a kite? That's because two pairs of consecutive congruent sides, which are right there. Now, if those were both 50, we could call it a rhombus. But they're not, isn't the case, we are going to call it a kite. Next shape we look at, I have parallel sides, one pair. So I can eliminate a kite from that, so I know it's definitely not a kite. 64 and 80, 75 and 62. Well, if we think about diagonals, what have we done with diagonals? We've seen if they bisect each other. These clearly do not bisect each other. They're not the same numbers. We also saw the diagonals could be congruent. Okay, well, 64 and 80 is 144. 75 and 62 is 137. So diagonals are congruent either. So we strictly can go off the fact we have one pair of parallel sides. Since that's the case, we are going to call it a trapezoid. If the diagonals were the same, these numbers matched, we could call it isosceles trapezoid. Not the case, we just have one pair of parallel sides. Okay, finally our last one here. We have one pair of opposite sides that are congruent. So looking off what we know, maybe isosceles trapezoid is the only one that works for that, but we don't have any parallel sides, so that's out. I have this 9 here, which there's no other value here, so I can't use opposite sides are congruent. I have this diagonal is bisected, but I don't know the other one. This one's really, looking here, is I'm missing something else. If I had a little bit more information, maybe these were congruent or bisected, what this one would be. I could go a little bit further, but I can't. I don't have anything to label it on. I could sit here and look at all the properties I have on this tree, and I don't have anything to give it something specific. So that happens sometimes. If that's the case, we're just going to call it a quadrilateral because that's what it is. It does have 4 sides, but there's nothing else we can use to be more specific about it. So we could explain, not enough information. It just doesn't fit. We don't have enough answers there. So hopefully you can get to work on the homework from here. Use that diagram as you go.